Data centers, technologies, leadership, business opportunities, and digital transformation across industries. How third-party data centers enable advanced modeling, data management, high-performance computing, real-time analytics, and intelligent applications across business, industry, government, and research. Data centers have become one of the most important components of the modern digital economy. Almost every sector, including government, finance, healthcare, manufacturing, transportation, telecommunications, education, mining, defense, agriculture, energy, water, and scientific research, depends on data centers to store, process, analyze, and protect critical information. The rapid growth of artificial intelligence, AI agents, cloud computing, digital twins, the Internet of Things, IoT, high-performance computing, HPC, big data analytics, robotics, blockchain, and quantum technologies has significantly increased demand for highly secure and scalable third-party data centers. These facilities have evolved far beyond simple data storage. They are now intelligent computational platforms that enable advanced modeling, scientific simulation, business intelligence, automation, real-time decision-making, and digital transformation. Rather than investing millions of dollars in building and maintaining their own computing infrastructure, organizations increasingly utilize third-party data centers that provide computing resources as on-demand services. This business model allows organizations to access world-class computational capabilities while reducing capital expenditure and improving operational flexibility. This article examines the technologies, stakeholders, business opportunities, applications, costs, security, challenges, and future possibilities associated with third-party data centers. 1. What is a third-party data center? A third-party data center is an independently owned and professionally managed facility that provides computing, networking, storage, cloud services, cybersecurity, disaster recovery, and digital infrastructure to multiple organizations. Typical services include cloud computing, data storage, high-performance computing, artificial intelligence platforms, machine learning infrastructure, database hosting, virtualization, backup and disaster recovery, network connectivity, cybersecurity services, edge computing, AI model hosting. These services are delivered using scalable cloud architectures and pay-as-you-use pricing models. 2. Technologies used in modern data centers. Modern data centers integrate multiple advanced technologies. Cloud computing provides virtualized computing resources that users can access remotely. High-performance computing, HPC, supports computationally intensive applications such as computational fluid dynamics, weather forecasting, genomics, drug discovery, financial modeling, engineering simulations. Artificial intelligence AI supports predictive maintenance, resource optimization, security monitoring, energy management, fault prediction. AI agents. Autonomous AI agents increasingly perform infrastructure monitoring, capacity planning, incident response, security management, operational optimization. Digital twins, digital replicas of physical infrastructure, enable simulation, scenario analysis, predictive maintenance, operational optimization. Internet of Things, IoT, millions of sensors continuously monitor temperature, humidity, power usage, cooling systems, network performance. Edge computing. Edge nodes process time-sensitive data closer to users before transferring selected information to central data centers. Quantum computing. Emerging hybrid quantum classical systems are beginning to integrate with cloud data centers to solve highly complex optimization and simulation problems. 3. Major stakeholders in the data center industry. The data center ecosystem includes many participants. Owners and investors responsible for capital investment, strategic planning, expansion, financial performance. Executive leaders including chief executive officers, chief information officers, chief technology officers, chief digital officers. They define long-term business strategies. Data center managers responsible for operations, maintenance, capacity management, compliance, service delivery. Operators manage daily operations, server infrastructure, monitoring, incident management. Engineers including electrical engineers, mechanical engineers, civil engineers, network engineers, software engineers, AI engineers, cybersecurity engineers. Contractors responsible for construction, electrical installation, mechanical systems, cooling infrastructure. Maintenance consultants provide expertise in digital transformation, cloud migration, AI adoption, energy optimization. Cybersecurity, sustainability. Governments regulate, privacy, cybersecurity, critical infrastructure, environmental standards, national digital strategies. End users clients include banks, hospitals, universities, manufacturers, mining companies, defense organizations, water utilities, energy providers, retail businesses, small and medium enterprises. 4. Applications across different industries. Third-party data centers support a wide range of applications. Healthcare applications include electronic health records, medical imaging, AI-assisted diagnosis, genomics, telemedicine. Manufacturing applications include smart factories, predictive maintenance, robotics, digital twins, supply chain optimization. Finance applications include algorithmic trading, fraud detection, credit risk analysis, portfolio optimization, regulatory reporting. Water management applications include water quality monitoring, hydraulic modeling, desalination optimization, flood prediction. Energy applications include smart grids, renewable energy optimization, demand forecasting, asset monitoring. Fire engineering applications include CFD fire modeling, smoke simulations, emergency planning, risk analysis. Transportation applications include traffic optimization, autonomous vehicles, airport operations, railway management. Education applications include online learning, research computing, virtual laboratories, AI education platforms. 5. High-performance computing and scientific modeling. Third-party data centers provide HPC resources for advanced scientific computing. Typical applications include computational fluid dynamics, finite element analysis, climate modeling, molecular dynamics, quantum simulations, structural engineering, geotechnical analysis. Parallel computing platforms utilize thousands of CPU cores, GPU clusters, high-speed networking, distributed storage. These capabilities dramatically reduce computation times. 6. Real-time analytics and intelligent decision-making. Modern organizations increasingly rely on real-time analytics. Typical architecture: sensors, right-pointing arrow, edge devices, right-pointing arrow, data center, right-pointing arrow, AI models, right-pointing arrow, decision support, right-pointing arrow. Operational response applications include smart cities, industrial automation, predictive maintenance, emergency management, financial monitoring, environmental monitoring. AI continuously analyzes streaming data to identify anomalies, predict failures, and recommend corrective actions. 7. Data management and business intelligence. Data centers support every stage of the data lifecycle. These include data acquisition, data integration, data cleansing, data warehousing, big data storage, data governance, analytics, reporting, archiving. Business intelligence platforms generate dashboards that support strategic decision-making. 8. Cybersecurity and information protection. Cybersecurity is a core function of modern data centers. Security measures include encryption, multi-factor authentication, identity and access management, zero-trust architecture, intrusion detection, security information and event management, network segmentation, disaster recovery. Future systems will increasingly incorporate post-quantum cryptography, quantum key distribution, AI-driven threat detection. 9. Costs and economic considerations. Building an enterprise-scale data center may require investments ranging from tens of millions to several billion Australian dollars, depending on capacity, redundancy, and specialized infrastructure. Third-party data centers reduce these costs by offering infrastructure as a service, IaaS, platform as a service, PaaS, software as a service, SaaS. High-performance computing as a service, AI as a service, quantum computing as a service. Operating expenses typically include compute resources, storage, networking, data transfer, managed services, technical support. The pay-as-you-use model enables organizations to scale resources according to demand. 10. Business benefits. The adoption of third-party data centers delivers numerous advantages. Financial benefits: lower capital expenditure, reduced operational costs, predictable budgeting, faster return on investment. Technical benefits: scalability, high availability, global accessibility, high-performance computing, continuous innovation. Operational benefits: improved productivity, faster deployment, better disaster recovery, business continuity, enhanced collaboration. Strategic benefits: digital transformation, faster innovation, competitive advantage, improved customer experience, data-driven decision-making. 11. Real-life applications. Examples include banks processing millions of financial transactions daily, hospitals securely storing and analyzing medical records, Universities running large-scale AI and scientific research. Mining companies analyzing geological data. Governments operating digital public services. Manufacturers using digital twins for production optimization. Water authorities managing smart water networks. Energy companies optimizing electricity grids. Emergency agencies conducting disaster modeling. Retail organizations delivering global e-commerce services. 12. Challenges and issues. Despite their benefits, third-party data centers face several challenges. Cybersecurity threats. Sophisticated cyber attacks continue to evolve. Energy consumption. Large facilities consume significant amounts of electricity. Cooling requirements. Cooling systems represent a major operational cost. Environmental sustainability. Reducing carbon emissions remains a priority. Data sovereignty. Many organizations require data to remain within national borders. Skills shortages. Demand for AI, cybersecurity, cloud, and data engineering professionals continues to grow. Regulatory compliance. Organizations must comply with privacy, security, and industry regulations. 13. Emerging technologies and future possibilities. The next generation of data centers will increasingly integrate artificial intelligence, AI agents, quantum computing, quantum machine learning, quantum networking, digital twins, edge computing, blockchain, robotics, autonomous operations, photonic computing, advanced liquid cooling, renewable energy integration, sustainable green data centers, 6G networks. Future autonomous data centers may use AI agents to manage infrastructure, optimize energy consumption, predict failures, coordinate cybersecurity responses, and automate maintenance with minimal human intervention. 14. Adoption, uses, consultancy, collaboration, and business opportunities. The rapid expansion of digital infrastructure presents substantial opportunities for business and academia. Potential activities include digital transformation consulting, cloud migration services, AI and AI agent implementation, cybersecurity consulting, digital twin development, HPC consulting, sustainability and energy optimization, executive education and professional training, industry-funded research, government grant projects, joint technology development, international research collaborations. Opportunities exist for consultants, engineers, universities, technology companies, systems integrators, software developers, infrastructure providers, and government agencies to collaborate on innovative digital solutions that improve productivity, resilience, sustainability, and economic growth. Conclusion: third-party data centers have become strategic digital infrastructure that underpins modern economies. They provide the computational power, storage, connectivity, security, and intelligence services required to support advanced modeling, high-performance computing, real-time analytics, artificial intelligence, digital twins, and emerging quantum technologies across virtually every industry. Their role extends far beyond hosting servers. They enable scientific discovery, accelerate digital transformation, support critical national infrastructure, and create new business models based on scalable digital services. As AI agents, quantum technologies, cloud computing, and autonomous systems continue to mature, third-party data centers will become even more intelligent, secure, sustainable, and interconnected. Organizations that invest in these technologies and build strong partnerships with data center providers, researchers, consultants, and governments will be well positioned to lead the next generation of innovation, economic development, and global digital competitiveness. If you enjoyed this discussion, don't forget to subscribe, like, and share. Stay tuned for more insights on AI, quantum computing, and emerging technologies shaping the future of software and humanity.